When I introduced the term AGI, the AI market was real, but AGI was beyond the pale. Everyone was laughing at us like, if this means adjusted gross income, no one will ever pay attention to you. Invention often happens actually by bricolage and cobbling together to make something happen. And the most elegant, simple Occam's razor way often comes later. While I'm not an optimist that LLMs can lead to human level AGI, because I think they don't have creativity in a fundamental sense, I am an optimist that LLMs could take over like 95% of human jobs. I just think that 95% of human jobs can be done without fundamental creativity or inventiveness. Human value systems are complex, self contradictory, incoherent, heterogeneous, always changing. They're evolving. The AGI's value system, I think, can be more coherent than human values, but will also be evolving. And you'd like there to be give and take and mutual information between the two.
Welcome to the Future of Life Institute podcast. My name is Gus Docker, and I'm here with Ben Goertzel, who is the CEO of SingularityNet. Ben, welcome to the podcast.
Good to be here. Thanks for having me.
You have been in the AI game for a long time. When did you get your PhD in AI again?
My PhD was in '89, which was in mathematics rather than AI. But I was in fact doing AI research as a grad student before I got my PhD, and I probably wrote my first lines of attempted AI code in '79 or '80. Like, I mean, well, before college even. I mean, as you know, but many people don't. AI has been around for some time, right? I mean, I'm pretty old. The AI field is even older than me.
What first convinced you that we could see artificial general intelligence in your lifetime?
It was probably 1973 or so. I found a book in the town library in Haddonfield, New Jersey, where we had moved recently, and it was called the Prometheus Project, written by Princeton physicist Gerald Feinberg, and he laid out a fairly coherent argument that within the next few decades, we would get machines smarter than people, strong nanotech to build machines out of molecules, and then be able to fix the human body so we didn't age and die. And he said this could be used for many purposes. Could be used for consciousness expansion. Could be used for mindless consumerism. He thought that should be decided democratically, and he was trying to get the UN to undertake some global education and voting process to decide, to what end to put all these amazing new technologies that were in the wind. So I'd seen these ideas in science fiction before that, but then I was, I guess, age 7 or something, 8. I seeing this scientist lay out these ideas in a non-fictional form was quite interesting. Of course, not having the web then, there was no way to contact other crazy people who also took this stuff seriously. But the argument seemed quite credible to me. And then in the late '70s, when personal computers you could program at home started to become a thing, I mean, that seemed very much in the line with this same vision that Feinberg had laid out, right? I mean, his book was basically The Singularity is Near, published in 1968, right? And as I later found out, Valentin Turchin had published a book in Russia called The Phenomenon of Science, late 1960s as well, laying out basically the same ideas. So, I mean, if you were paying attention, these concepts were always there, and honestly, they already seemed sensible, just given the advance of computers already at that point, right?
That doesn't seem obvious to me, given how primitive computers were in the early 70s. It doesn't seem obvious that you would be able to project from there that we would get something smarter than humans.
I mean, I.J. Good wrote his paper on the intelligence explosion in '65, which is the year before I was born. And if you look back at the work of McCulloch Pitts and Turing, all these guys in the 40s and 50s, it was already quite clear from a at least math and physics and biology view. Like it was clear, you know, brains can be viewed as computing devices, and we're building general purpose computers, and they're getting faster and faster and can do more and more step by step. Like we could beat the world champion of checkers in the late 1960s, right? You didn't get chess till the 90s, but I mean, you had already in the early 70s, you had the early versions of what would become Mathematica on Maple. You had computer algebra. I mean, there's a lot of stuff, and historically, actually in the late 60s, there was a lot of AI over optimism, right? I mean, there was a lot of people at that time saying, wow, look at all this amazing stuff computers can do. So, yeah, obviously they're going to overtake humans pretty soon. So I think actually a lot of people were seeing it that way back then because that happened to be like before the series of AI winters and summers set in. I think when I was a little kid first reading about this stuff, AI was still in like its first blush of excitement before people realized how difficult it was in some ways. But yeah, it wasn't obvious like it is now, right? I mean, now of course everything has changed since Chat GPT, and average people are like, well, yeah. You mean the machine isn't smarter than people already? Are you sure? Like, yeah, there's no shock value in the concept of superhuman intelligence at all now. Certainly wasn't like that in the early 70s. I mean, you had to pay attention and do your research and background reading and then think with an open mind. But on the other hand, it's not like I had to invent the idea on my own either. It's like a small town library. There's a paperback book by a Princeton physicist laying out the whole argument for super AGI and singularity, right? I mean, the ideas are there and from sources that seemed reasonably mainstream and credible, right? It just the way culture goes, it takes a long time for things to get from that stage to really becoming dominant.
What feels different about the AI moment we're in right now? You could count that moments starting from say 2012 where deep learning begins to really work. You could count it from 2022 when ChatGPT becomes something that everyone knows about. Does something feel different about this wave of AI from a technical point of view?
Clearly, the impact of scale has been the main factor. And while I don't really think LLMs or standard deep neural nets are the route to AGI, I I do think the factor of increasing scale of compute and data, which has allowed the LLM revolution to happen. I mean, I think that is the same primary underlying factor that will let AGI happen, right? So I mean the AI field had a lot of good ideas for a long time. I mean, they were doing automated theorem proving in the late 60s when I was a little baby, right? John Holland invented evolutionary learning genetic algorithms in the 70s. There were multi-layer perceptrons in late 60s, early 70s, which are would now be called deep neural nets, right? I mean, this stuff has been around a while, but when I was teaching deep neural networks at University of Western Australia in the mid 90s, when I was an academic earlier in my career before I went to industry, I mean, we were doing multi-layer perceptrons with recurrent back propagation, and it took like 3 hours on the fast Sun workstation to train a network with like 35 neurons, right? So it wasn't actually that the ideas were way off or something. It was mostly that without greater scale of compute and then greater scale of data as a secondary point, really. I mean, without that, you couldn't refine and tweak and adjust the ideas until they actually work. So you were just left with the initial conceptual version of things. So I mean, scale makes a huge difference. It means that you can run experiments in minutes that would have taken like years earlier in my career, literally, right? So I mean, that's quite big. I mean, I think we're also now, as of the last 6 months or so, we're at the point where AI technology is aggressively accelerating the speed of creation of AI technology, right? Like you can't use LLMs to write AGI yet. I mean, they're bad at doing complex original thinking, but I mean, you can use them to generate unit tests. You can use them to take your rough notes and turn them into a structured paper for your colleagues. You can use them to write scripts, right? So I mean, already, like I'm concretely seeing on a technical level stuff that would have taken me 5 days takes one day or something, right? So I think we're already at the point where AI is accelerating the creation of AI, and that came because of scale, but it's now a separate thing on its own. And I think the cultural and kind of attitudinal aspect is important and is very different now also, right? Like when I introduced the term AGI in 2003, 4, 5, I mean, we introduced it as the title of a book we were editing, and that book was finally published 2005, I think, from Springer. Just edited a bunch of papers called Artificial General Intelligence. But then you really couldn't do like a workshop or a session on human level thinking machines at a normal AI conference, be it a neural net conference or a triple AI, IchKai, whatever. Like it was you talked about it in the bar afterwards when you were talking about reincarnation and backwards time travel or something, right? So it was like it was way out there, and that made a big difference. I mean, it meant that only really dedicated or really crazy people were going to work on AGI because it was kind of career suicide, right? Like when I got my PhD in '89, AI as a whole was career suicide, and I mean, I did my PhD in numerical analysis for that reason in math. Then when I wanted to switch to computer science, I did computer graphics because there were no jobs in AI, and graphics was also math heavy, right? Now, by the early aughts, when I introduced the term AGI, the AI market was real. Like it was okay. There were industry jobs in AI, there were university jobs in AI, but AGI was still beyond the pale, right? And I remember when we put that term out there, everyone was laughing at us like, if this means adjusted gross income, no one will ever pay attention to you. Been sort of watching like, when will AGI as artificial general intelligence overtake adjusted gross income in the Google search ranking, right? And it's depends on how you count now, right? Not now they're actually they're in competition. But yeah, at that time you couldn't talk about AGI like even like an academic seminar in a top university or something. So the fact that the attitude has shifted so much now makes a big difference. I mean, it means it's feasible to get funding to do AGI projects. I mean, it's still very hard because getting funding for anything is very hard, but it's no longer very, 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 very hard. It's only very hard, right? And I mean, you can much more easily get like bright young students who care about their career to plunge into AGI, whereas previously it just didn't seem like a practical thing to do. It's probably made the human constitution of the field less interesting because I think when you had to fight and be a crazed maverick to pursue AGI, you had a lot of interesting characters who were thinking all day for decades about how to make thinking machines. And the first AGI conferences I organized in 2006, 8, 9, and so on were sort of like that. Now it's a morally acceptable thing to do, and you can make money at it. But the change in attitude is important along with the technical aspects, I think.
Yeah. So something seems to have happened since ChatGPT went mainstream, where it is now basically mainstream to talk about AGI and perhaps even superintelligence.
Almost all people only take seriously what they can put their hands on it and see in front of them, right? And I mean that includes political decision makers and CEOs and so forth. Like there's not that many people who will take more seriously something they can project and imagine than something they see in front of them, right? So yeah, once you had ChatGPT there, I mean, sounds like it's intelligent. It can do a lot of stuff that has the vibe of intelligence, and that definitely qualitatively convinced everyone. Like, holy shit, AGI might really be near. It was interesting. I found almost everyone after they spent some number of hours playing with LLMs, they could also see these are not AGI, and they could intuitively understand why, even without a technical background. But I mean, still, that's like you want to convince people you can fly to the moon. Well, if you send a rocket up really high, so far you can't see it, then it comes back down. More people are going to believe you could possibly go all the way to the moon, right? I mean, that's pretty simple to understand.
I think we've shot ourselves in the foot, and I'm thinking of society at large here, by making AGI a topic that couldn't be discussed for a long time. What do you think we've lost from not having a longer conversation, and a conversation in kind of prestigious venues about AGI for longer?
I'm not all that sure that the conversations in prestigious venues are usually that valuable anyway. I feel like our species generally deals with things at the last minute and after the fact rather than in foresight. And when people are trying to figure something out in foresight, it becomes mostly a projection of their own ego or their own imagination on the thing anyway. So I mean, I think by not taking AGI seriously, we're getting it later than we could have otherwise. I mean, I think we could have built human level AGI some years ago. We could have built it on massively parallel hardware, which was kind of became less of a focus of the field a long time ago. So I mean, certainly if we had a rational world government in 1970, right, then that government had said, let's develop safe, beneficial AGI as a priority of our species, which is what Feinberg was promoting in Prometheus Project. I mean, I think we would have an AGI well before now. So I mean, resource just wasn't put on it. In terms of thinking through the sort of ethical, social, political, human implications of AGI, I mean, we haven't done a good job of thinking through things like disarmament or combating world hunger, or I mean, a lot of other much more basic stuff. Like we're still struggling with like trans athletes in sports competitions or something, right? So sort of I guess if this idea had been taken more seriously in the human population at large, you would have had more diverse creativity and more different ways of thinking popping up regarding the theme. But I'm not currently all that positive on our social and political institutions being able to think through very very hard issues in a useful way. Like we're still blowing each other up all around the world, and 60% of kids in Ethiopia die of not don't die, but their brain stunted due to malnutrition. Right. So I mean, as I've seen through our AI office in that country. So I mean, we're even the issues that are out there. Like I've been hearing about world hunger and disarmament since I was a baby, right? We seem to suck at dealing with those relatively very simple things, right? Like shouldn't be that hard to stop blowing each other up over territorial disputes and to like send send food to little kids. But we're not even good at that, right? So I don't know how much brilliance we would have brought to bear on the social issues about AGI, even if they'd been sort of more at the forefront.
You mentioned that neural nets it's an idea that's been out there for a while, and we didn't have the scale of data and compute for these neural nets to actually work in a convincing way. I guess that took GPUs developed for originally for gaming, but also data being created and published on the internet for all the ingredients to come together to for neural nets to work. If you look back through the history of AI as a field, do you think there are other hidden gems that might, where the theory is sound, but we don't have the scale or the implementation for it to work yet?
A high percentage of the historical AI paradigms probably actually will work when you scale them up enough, and you can see that when you dig into the details. So if you look at genetic algorithms and genetic programming, so use of algorithms modeling evolution by natural selection to learn things. I mean, there was a whole body of work by David Goldberg at University of Illinois and others. He had a book on the design of innovation and another book on competent evolutionary learning or something. I mean, competent genetic algorithms. So all this work from the 80s and 90s was about using evolutionary algorithms to solve problems, but then doing kind of back of the envelope estimates of how much resource you should need for these algorithms. So like if you're trying to maximize a certain fitness function using a genetic algorithm, what's your optimal population size beyond which you're getting diminishing returns? And those optimal population sizes, when I calculated them back in the 90s, they were always like orders of magnitude bigger than what we could do on computers then. So I'm just like, well, okay, life isn't optimal. We're not going to do the optimal population size here. We'll just do what we can. And then genetic algorithms are good at solving some problems, but they just take forever or don't work well for solving other problems. So, I mean, in that case, I mean, you have decades old theory giving reasonably strong reasons to believe it can work much better when you scale that much bigger. Now, if you look at logic based AI, which goes back to the 60s, I mean, again, due to lack of data, really, logic based AI got it started with this sort of stupid methodology of people hand coding common sense knowledge. Like you would type, like a human would literally type a logical formula like grass is green, lawnmowers are used to mow grass in predicate logic form. And
Maybe explain what the purpose, what was the vision here?
yeah, so the idea with logic based AI was that, I mean, what makes humans so different than apes and bunnies and so forth is largely our ability to do advanced logical reasoning in math and science and philosophy and whatnot. And the idea was sort of that this capability emerges almost as a kind of virtual machine on top of the lower level animal like machinery for seeing it and moving. So maybe you can just implement that module in a way that doesn't depend that much on the underlying neural substrate. And I mean, in that direction, a calculator does arithmetic very well. Computer algebra systems do algebra very well, and they don't try to emulate exactly how the human brain does it. You just abstracted some rules and procedures, right? And then the issue you run up against is twofold. I mean, one is okay, but where does all the knowledge come from? Because humans, even when we're doing logical reasoning, in the end, we're getting the knowledge from seeing and acting, and that then you still have problems of scale because the human brain is doing logical reasoning when it's doing it on a tremendous amount of knowledge, right? So there was an attempt to work around that problem in the AI field, still going on till now in some areas, but it was a major thing in the 90s anyway. And in the late 80s when I got my PhD, which is part of why I ended up doing a PhD in math rather than AI, because this whole paradigm made no sense to me. But I mean, there basically the idea was just type in the type in the formal knowledge, right? Like if people eat steak, type in a predicate argument relation, eats parenthesis people comma state close parenthesis, right? And just type in common sense knowledge about the world, and then your logical reasoning system will reason based on that. And that never seemed sensible to me for the reasons that are obvious to everyone now. Like the amount of knowledge is just too much. It's fuzzy. It's probabilistic. It's messy, right? But on the other hand, there's an argument that logic-based AI was inappropriately tarred and feathered because of its historical association with the hand coding of knowledge. Because you can take a logic system and you can connect it to a camera and a microphone, right? And you can connect it to an actuator. Like the actual formal mechanism of using logical inference as a core engine of an AGI. I mean, that's not tied. It's not tied to that old idea of typing in hand coded knowledge, right? And now a couple things are different. One thing is you can use LLMs to translate natural language into logic formulas, right? So the late last 6 months worth of top LLMs, you can have them take an English sentence and output a bunch of higher order predicate logic or dependent type logic, whatever you want. So you can get a humongous corpus of logic expressions to feed into your logic system without having people type them in. I mean, you can also write converters from sensory data into logic expression form, and then you have a scaling problem, right? Then you says, okay, well, great, I have literally trillions of higher order predicate logic expressions. How do I do reasoning based on this, right? And so that's something that the historical logic based AI field just couldn't explore, right? So I think in some ways the AI field wasted a lot of time trying to accommodate for limited compute resources. So in logic based AI, because you couldn't do reasoning on the trillion premises, you would spend a lot of time trying to craft the best 500 premises. But it turns out that was just a time wasting way to do things. And we did a lot of tricks to get good results out of genetic algorithms with a population size of a couple thousand. It turns out that's entirely useless now, and it's it's actually much easier. You have them to. It's much easier to get them to do good things if you just jack up the population size, right? And it requires less thinking and less work. I mean, it's sort of like all the work that went into making chess or Go playing engines before we got a machine learning based approach. There were very complex rule based approaches to try to outdo like basic alpha beta pruning for playing these games. No, that's all. It's all irrelevant, right? So yeah, I think evolutionary learning, logic based AI. Another example is hypervectors, which was big with it was big in the 80s and 90s. People were talking about high dimensional sparse vectors to model episodic memory and so forth. And you just couldn't do it at large enough scale. The last 5 years, there's a huge literature on doing all sorts of memory with hypervectors, hypervector based chips, and so forth. So, yeah, my view is that the use of modern scaled up compute tech and data to accelerate back propagation based deep neural nets historically is going to seem like that just happened to be the thing that got scaled up first, right? And we're going to see a bunch of other historical AI paradigms get scaled up over the next few years, and then it's by connecting together these scaled up versions of these various historical AI paradigms. It's by connecting them together that we'll probably get to the first AGI, and that at that level, this is not even such a controversial point of view. I think the question about AGI architecture, on whose answer I probably differ from most deep neural net big tech people now, is you could say, well, let's take a deep neural net like an LLM, use it as the hub, then add some evolutionary learning, some logic engines, add a long-term memory, add a working memory, like add these things on the periphery around the central component of your AGI architecture, which is an LLM. I don't think that's going to work to get to full on human level AGI, although I think it could work to get to something doing 95% of human jobs, which is how some outlets tried to redefine AGI. I don't think it can get to a system that can really generalize beyond its experience after the fashion of people, which is the meaning that I had for the term AGI when I introduced it. But I think if you take something else more flexible and more introspective and make it the central component, then an LLM can be one of the very powerful things cooperating with that central hub and feeding it knowledge and helping it synthesize things. So I guess one question about AG architecture is: do you want a monolithic or a sort of hybrid approach? Like, is it only LLM, only logic engine, or multiple components? Another is, if you have multiple components, is there one that's sort of more central, and if so, which is it, right? And this sort of debate, I think, isn't resolved within the AGI R&D community, and it might be you could build many different sorts of AGIs by kind of mixing and matching and combining historical AI components that have been scaled up in different ways.
Do you think these limitations are fundamental, so that we need different approaches working together in order to get AGI?
I think that what are different approaches and what aren't is almost a matter of culture or mindset rather than math. So I published a paper or posted on ArcSci a paper, but there was a short version published in the AGI conference series called Patterns of Cognition, where I tried to show that all the core algorithms that we're using in my OpenCog Hyperon project, which include logical reasoning, some variations of attractor neural nets, evolutionary learning, some concept formation, I tried to show that all of these can be cast as basically forms of approximate stochastic dynamic programming. So you can sort of take a whole bunch of AI algorithms that look really different, and you can actually cast them in a common mathematical form. It's just not the way people are typically looking at this, right? And I mean, the reason I did that exploration is I was trying to make sure the infrastructure for our new OpenCog Hyperon system would let all these things run fast. So if I could reduce them to a common mathematical form, then there's just one thing that you have to make work fast, right? So yeah, what's the same or different kind of depends on your perspective. Like in mathematics, you see this all the time, right? Like in algebra, you have homomorphism between structures. In topology, you have homeomorphism. They seem different but kind of similar. Then category theory was invented. It's like, no, these are all morphisms, right? And so you can see that what seem to be different branches of math done by different people coming out of different historical lineages, actually what they were doing were kind of trivially seen as specializations of the same thing, and now everyone accepts they're the same thing. So I mean, for sort of tribal reasons, we're looking at deep neural nets and logic systems as like super different things. But like when you're in code working with these things, so we have in OpenCog Hyperon, which is my big AGI project now, we have a network of nodes and links, and the nodes and links can have symbolic types or floating point numbers associated with them. They have update rules associated with them. Now, pretty much the difference between a neural net put into this network and a probabilistic logic system put into this network, it's like, what little nonlinear algebra function do you put in the node to update the numbers that are coming in and going out, right? So I mean, it is different. It's a different way of thinking, but it's not like building a computer out of cells from a slime mold versus building it out of diamondoid nanotech or something, right? I mean, they're actually just, in every case, we're propagating numerical values through these node and link networks in the machine, and then we're debating about what nonlinear function do we use to translate the input numbers into an output number. But because people are tribal and like to fight over ego and resources, these start to seem like totally opposite camps with totally different ways of thinking. Because I mean, really, a neural net is quite loosely connected with the brain anyway. So I mean, people like to say it's biologically inspired in a very distant historical way. It is, but like there's no backprop in the brain. You do have astrocytes and glia and extracellular charge diffusion in the brain. So like a lot a lot of the differences between the AI paradigms are not that big. I mean, you have evolutionary learning, but then in the 80s you had Edelman's neural Darwinism, which claimed that the neural assemblies in the brain are evolving by natural selection, right? So I mean, you could make a decent argument that just as sort of physics, computer science, and math are converging into one thing, all these different AI paradigms are looking more and more similar as things progress.
Wouldn't you expect us to build the first AGI using the simplest methods available, and the first AGI we build will be built using the easiest way to build an AGI, and I would guess that that method is not a combination of methods, but rather something very simple that you can scale.
Honestly, that doesn't seem to be how software development usually works, or math actually. Usually, the first way you do something is kind of a kludge, and is just it was easiest for you to do given the materials at hand and given your point of view then. But then you like in mathematics, often the first proof of something is a big, horrible, ugly mess. Then like 50 years later, you realize how simple and elegant it actually was. We could also argue that modern electric cars are going to be a lot simpler than the internal combustion engines and so forth. So yeah, I think invention often happens actually by bricolage and cobbling together the shit that you have available to make something happen. And the most elegant, simple Occam's razor way often comes later. I mean, certainly, like physics is a mess. The standard model of physics is a mess. Now everyone thinks there's going to be something a lot simpler, but the early quantum mechanics was also way messier than the new quantum mechanics of Heisenberg and Schrodinger and so on. Right? It was a mess of stuff adapted from classical physics. So yeah, I don't. Also, scale plays a big role here because something like Marcus Hooter's AXE or Jürgen Schmidhuber's Gödel machine or similar ideas I had even before I read that. I mean, there's mathematical arguments. You can make a really, really, really simple AGI if you just had a big enough computer, right? Because in effect, these really simple AGI algorithms involve brute force searches over large spaces of programs. Like so, like if before you take each action, you can search all programs up to a certain size and figure out which one, if you executed it, would lead you to the best action, right? Then you just run that. Then that's much easier than doing all the garbage we do in modern AI systems. The problem is anything approaching a brute force search over program space is just infeasible using current hardware. Now, will it be infeasible using like a femto computer or Atto computer or something? I mean, you can't truly do complete enumeration over program space, but you could do things much closer to a brute force search over program space if you had massively more hardware. So it might be that once we've gotten sufficiently powerful hardware, which could end up being a few years post singularity, who knows, right? And maybe once you're there, you can radically simplify AI algorithms more in the direction of Gödel machines and AXE and whatnot. Because I think much of the complexity in modern AI is working around resource limitations. And the resource limitations themselves are not simple, they're particular, right? Like, so we have GPU and CPU, we have cache RAM, we have main RAM, we have networks of computers with certain bandwidth. So it seems like as long as your infrastructure is heterogeneous in its resource limitations, you're going to end up wanting to adapt your AGI system to be somewhat heterogeneous in its operation for efficient operation on that infrastructure. So then that's like simplicity conditional on your infrastructure and your data. But simplicity conditional on your infrastructure and data is not the same as simplicity by our own intuition, like you get AXE or Gödel machine, right? So yeah, the other thing I would say though is simplicity in a deep tech stack is often carefully engineered on top of a lot of complexity, right? So like it's also like it seems simple to us to walk down the street because we're not aware of what's happening in our cerebellum. And writing a Python script to train a deep neural model seems really simple until you try to write the the CUDA code running on the NVIDIA GPU to make the matrix multiplication algorithm manage the cache RAM, all the different layers of processors inside the NVIDIA GPU, right? So I mean, we built things so the type level that most people have to deal with looks simple, but it's really like a quite complex stack working around the strengths and weaknesses of the underlying infrastructure. And this is often top of mind because trying to build an approach that isn't just deep neural nets like we're doing in Hyperon, we have this weighted labeled metagraph thing called the Adam space, which is the central sort of knowledge structure of our system. But you got to rebuild a whole tech stack then because these are not rooted in matrix multiplication. Most of the graph algorithms that we're dealing with here. And so if you're trying to make a different AI paradigm, it's not just scripting a different algorithm. It's repurposing pieces to build a whole different tech stack down to the chip level, right? So there's a lot of complexity, and this is why you have to view AGI as being built by like a whole huge combination of industries, right? Like, I mean, we'll give a Turing Award to the guy who like tweaks the back propagation algorithm to converge better on recurrent nets or something, and that's all important. But obviously, if that guy was like sitting on a desert island and made that innovation, it's not going to make an AGI. Like it's forming this huge combination of hardware and software in innovations, which are mostly being pursued not because of AGI, but just because they're making somebody money or letting somebody look more powerful than their opponents, right?
Hmm. Hmm. Do you think physical embodiment is going to be necessary for AGI, and if so, why?
So I had a funny experience with this. I was giving a talk at a non-technical futurist conference, and I was talking even about people who were interested in embodiment for AI versus people who took a more disembodied approach. And this very new agey middle-aged lady came up to me with like a bunch of crystal jewelry and so forth. She's like, "Wow, I'm so amazed someone's finally talking about disembodied AI. Like I've been seeing these AI poltergeists in my house since forever, right?" And I'm like, "No, that even your poltergeist is not actually disembodied. Like it's embodied in an electromagnetic disturbance that we just don't fully understand, right?" Some Pei Wang, another longtime AI researcher who was a pioneer in the Chinese AGI scene in the 80s and 90s, he had a paper once called "A Laptop is a Body." Right. And I guess the point is your AI. I mean, it's always seeing something and doing something, right? So it's otherwise you as the programmer or tester could not be interacting with it either, right? So it's a question of a what sensory and motoric bandwidth are needed to get to certain kinds of AGI, and b to get human-like AGI as opposed to just arbitrarily intelligent AGI that might be off in a different direction than humans, right? To get human-like AGI, how much do you want to have a human-like embodiment? That's one. On the first question, I think robust embodiment is convenient, but probably not necessary. I would imagine you could get a vastly superhuman AGI with a much restricted sensorium and the motoric world than people have. And sort of depends on what you want to do. Like if you started by making a theorem prover and a sort of a scientific research assistant that's doing symbol manipulation, then you can give it limited insight into the physical world. It probably can work fine, right? And there's a lot of camera inputs to the internet that it can use without having its own body to tool around. There's two issues with that sort of approach. One is, of course, it's harder for us to know what's going on because if a mind you're building is very non-human, you don't have so much intuition to go on in designing and testing it. Then, but also a very non-human AGI like that, for better or worse, it will probably have less of a strong understanding of what it is to be human and human values and culture and all that, right? So I think there's a stronger argument that if we want an AGI we can relate to on a sort of Puberian I thou level, like relate to on a deep level, then then for that AGI to have something vaguely resembling a human embodiment is probably quite valuable, right? I mean, for the same reason, like I can empathize with other men better than with women in some ways. I can empathize with other people better than with apes or rats, right? I mean, having an embodiment like ours doesn't guarantee that it's empathic toward us or understands what we're up against as humans, but it kind of would give it a head start, right? So I think what we can do, certainly with a Hyperon type architecture and in different ways with deep neural net architectures. I mean, you can take proto AGI systems with different bodies and different levels of attachment to their embodiment. You can have them learn stuff, and you can then network them together and even merge their knowledge bases in some ways, right? So, which is something we can't do in the human sphere all that well. So, I mean, you can take a chat system, you can take an proto AGI system used to control a humanoid robot, you can take a system controlling biology lab equipment, and with some work and some caveats, I mean, you can have what's learned by all these systems combined together to synergize and feel like a sort of semi-coherent overall artificial mind. So I don't think it has to be either or. I do think though that the ease of doing things with embodiment is increasing very fast also, right? So I mean, so I worked for years with David Hansen at Hansen Robotics. We made Sophia the first robot citizen. I led the software team behind that. But now I'm still working with David, but we have a different robotics project called Mind Children. And in the last 9 months or so, we put together a 3.5 foot tall humanoid robot. It can look at you, it can talk, it pick things up. It's not walking, it has wheels, it rolls around the room. But the ease of making your own robot with the properties that you want for teaching and evaluating your proto AGI system, like it's incredibly easier than 5 years ago, let alone 20 years ago. So it's seems like what's happening is early stage proto AGI stuff is just being tried out in a variety of humanoid robots along with other applications, and then the knowledge bases just will get munched together somehow, so that the field isn't requiring itself to ask the either or question. We're just doing both, which is what you get from having more attention and resources into the field, generally speaking.
Do you think the notion of aligning AIs with human values makes sense? And what are the best approaches here?
Alignment is not a term or language that comes naturally to me, but I mean, I think the intention behind it is probably something fairly reasonable. The first thing I would note is people are not very well aligned with themselves, let alone with each other. So, what's the bar for alignment with humanity needs to be thought through carefully. Like I I've probably gotten more self-aware as I've gotten older through meditation and various other practices. But one of the things one becomes aware of then is how incoherent and non-unified one's own self is, right? So like I mean, when I visit sub-Saharan Africa, I will give a decent pile of money to poor suffering people I see in the street. When I come back home to the Seattle area, I send less money to those people, and I will go out and buy a piece of weird keyboard equipment to play music instead of sending all disposable income that I have to save kids who are starving in Africa. Yet, if I was in front of those kids and I had the chance, like buy food to give this kid right in front of me versus buy a keyboard, I would probably buy food to give that kid right in front of me and not own a keyboard, right? And just learn to play a cheaper instrument. So, I mean, I can see I myself, I'm not entirely morally coherent. I mean, I don't beat myself up too much. I've given a lot of money to initiatives in Africa and spent a lot of time on it, right? But and I don't feel the need to force myself to be entirely coherent either. I mean, I think most humans, probably all humans, were more like clusters of behavior patterns than like unified, rational, coherent entities. If we really are honest with ourselves, and that's even more so on the collective level, right? Like I mean, if I go through rural Ethiopia, which is a beautiful place where I love to travel, but the average people are heavily Ethiopian Orthodox Christian, right? And I mean, they don't think AGI will ever have a soul, even it will be much smarter than us. And I mean, the attitude there is rabidly homophobic, right? Whereas, I mean, my mom is gay. I was raised in a totally like queer friendly ambiance. Now, these are lovely people you meet in Ethiopian villages. They're just raised to believe that you'll burn in hell if you're gay, right? So I mean, if you look at the lack of alignment in each of our own minds, if we're honest with ourselves, and then the lack of alignment among different human beings, you got to ask, like, what exactly are we thinking the AGI is supposed to align to? Like, is it Elon Musk's value system? That doesn't seem very coherent either, right? Like, is it like the weighted average of all Silicon Valley VCs and software developers weighted by their bank account? I mean, or their IQ? Like, it's not really clear what you want to align with. So I end up thinking about it a little differently than that, but it may capture the spirit of what people are looking at with alignment.
One approach is to talk about some minimal set of commitments you would want the AIs aligned to. Something like you want the AIs to not destroy humanity, so not cause our extinction, and you want the AIs to to not be in complete control over humanity. So of course there's some people that disagree with those notions, but I think that's something that you would find quite wide agreement on among many humans.
I don't think the main issue with that is that some people would disagree with them. I think the main issue with that has been highlighted in science fiction since before I was born and was summarized very well by Eliezer Yudkowsky, who I differ with on a number of things, but I've known him since forever, and we agree on a lot of things too. I mean, he made the point that human values are complex, right? And we summarize them in natural language in ways that we culturally have a common understanding of. So it makes us think it's simple. But these things are really very, very ambiguous, and their interpretation as we think of it depends on a bunch of implicit cultural assumptions. And I mean, this was highlighted in the science fiction book The Humanoids that used to be required reading in MIT's AI department way back when, before AI was so popular. And in this book by Jack Williamson, which I read probably 75 or something when I was a kid, right? I mean, people create these human level intelligent humanoids, which are more physically powerful than humans, and they give them a mandate to serve and protect and guard men from harm, right? And everyone in my generation in the AI field read this book. And of course, they wouldn't let people use power tools. They wouldn't let people use hammers. Like in the end, if you were upset about your girlfriend dumping you, they would inject you with some euphoride because that obviously was causing you harm, right? So they interpreted serve and protect and guard men from harm in a different way than the authors had originally intended, right? And one of the lessons of the failure of rule-based expert system AI, where you code all the AI's knowledge by hand, one of the lessons there is like, even if you decide to refine serve and protect and guard men from harm into a whole volume of logic expressions, it's still not enough. Like there's always a loophole, there's always room for interpretation. And of course, this is why our legal system has case law, right? Because I mean, we try to enumerate law in detail, but then in the end, judges have to use nearest neighbor matching in a very fuzzy and informal way against a bunch of cases, which causes really annoying problems, as we see now in U.S. Supreme Court, right? But it's for the reason that Eliezer said, like human values are complex, and I mean, what we mean by something like "don't cause the extinction of humanity" seems like it's straightforward, but it's not straightforward. Like if because some people will argue that replacing human cells with genetically engineered cells is the end of humanity. Some will argue that is replacing it with like robotic cells is the end of humanity. Some would argue a brain chip implant is the end of humanity. Some would argue staring at your phone all day is the end of humanity. And you can try to enumerate every case, but you're basically guaranteed that the world will throw at you some case that wasn't in your enumeration of cases, right? For one thing, we don't have a formalization of the world, and we don't know what new technologies and trends are going to emerge. So the thing is that enumerating some principles you want the AGI to follow, of course you want to do it. Of course it makes sense, but it's foolish to think that's going to give you anything resembling a guarantee. Like I think those maxims have to be on top of some more implicit resonance of the AI with human values in it. This is sort of like raising human kids, right? Which I mean, I've have 5 kids and 1 granddaughter. You see, like giving your kids some core principles they have to obey, and telling them these principles over and over, or even rewarding and punishing them for obeying the principles or not. Like this does not work very well, right? I mean, and I mean, if you raise your kids with the right vibe of compassion and values, and you carry out activities together with them in which you're collectively pursuing activities in accordance with your values, and then on top of that, you tell them some core principles that sort of reify and abstract what they've gotten implicitly through the shared activity with you, like that can work reasonably well. And I mean, this is what education systems have always tried to do, right? So that, but now you might say you don't have to do that with an AI system. That's just because people are perverse. But I think for any human-like AGI architecture, it's going to be like that because you have this vast, teeming, massive, self-organizing activity that's conditioned based on experience, and then the rules and principles that you give it are just guiding this vast, teeming, massive, self-organizing activity. And that, in the end, that will be true if you have a huge logic engine as well as if you have a huge neural net. Because I mean, in any case, you've got a massive amount of stuff going on that's not predictable in detail by the programmer, and you need it to be making up its own stuff as it goes along, right? Like otherwise it's not going to get to human level of general intelligence. So yeah, going back to alignment or things resembling alignment that might be more meaningful or achievable. I mean, I think you can hope for compassion. You can try to get AGI systems that are empathic and compassionate to people, as well as declaratively understanding human values, which LLMs can already do. You can hope for AGI systems that are compassionate and have a working practical understanding of human values. You can also think about what I would call meta goals to put into an AGI system. So you can ask the AGI system to have as a value, as a meta goal, like don't change your top level goals very fast or heedlessly, right? Like I don't, I don't think it's fair or workable to try to build an AGI system that keeps the initial top level goals we gave it in precise form forever. I think if you do that, it will just try to work around them in various crazy ways. So, sort of like humanity has. Like we had a goal to reproduce. Hey, we invented birth control and we hacked around all the mechanisms there, right? So I think if you try to restrain AGI to rigidly hold the top level goals that the original programmers put in, like it won't work. Self organization will just kind of work around that, and you get a perverse system. I think it will. I think it could work better to make an AGI have a top level goal to evolve its top level goals in a sort of moderated and responsible way after interacting with the others in its environment and reflecting on itself carefully. So, I mean, I think you can design a meta goal system in a way that decreases the odds of the AGI system, like weirdly going off in a totally non-human direction. What you want is for it to have a top level value of evolving its own value system in a way that sort of has a high mutual information with the evolution of human value systems, right? Because human value systems are complex, self-contradictory, incoherent, heterogeneous, always changing. They're evolving. The AGI's value system, I think, can be more coherent than human values, but will also be evolving. And you'd like there to be give and take and mutual information between the two evolving value systems. And you can bake that into the value system of the AGI. Like, yeah, you're going to change your values as you do. Be sure you're closely connecting with human values as they change in that process. And if that probably is a species of alignment. It's just not what many people are thinking about when they're talking about alignment, because they seem to be thinking more like there's some core of human values and we can get the core of the AI's values just go alongside. Whereas my feeling is it's more like human values are going like that. And then you want the AI values to follow their own chaotic orbit, like sort of coupled a bit with the chaotic orbit of human values. And this perspective just makes it much harder to think about guarantees. And some people seem to want guarantees. And I don't think we're going to have guarantees. We're going to have very fudgily, probably approximately correct value systems rather than guaranteed value systems.
When you look at where we are with AI progress right now, we're seeing incredible performance on a number of benchmarks, math performance, programming abilities. AIs are passing all kinds of tests, college level exams. What does that mean for impact in the real world? Because I see the AI optimists being very impressed by these benchmarks, whereas the AI pessimists are asking questions such as, when will AI show up in productivity statistics or in GDP or in unemployment? And yeah, what do you think of that disagreement?
So I think the rollout of AI tech into the practical economy is gated by human stupidity, human culture, and human ego, and all the constructs that we have governing our world, right? So I think, yeah, while I'm not an optimist that LLMs can lead to human level AGI, because I think they don't have creativity in a fundamental sense, I am an optimist that LLMs, with minor additions and tweaks, could take over like 95% of human jobs. I agree with Sam Altman on that point. I just think that 95% of human jobs, I mean, as a vague hand wavy figure, can be done without fundamental creativity or inventiveness. So if you have a system that can do really clever nearest neighbor matching against everything people have done as recorded on the internet, like most of what people are doing is a repetition of something that's already been done and recorded on the internet, right? So I think that we could roll out deep neural net driven systems to do tremendous variety of human jobs right now. It's not happening that fast just because that's not how society and industry are organized, right? And then that becomes more a socio-psychological question. I mean, very simple example. Some friends of mine had a startup company called Apprente a number of years ago, and among other things, they automated the McDonald's drive-through, and it worked. I used the system. It was rolled out in some McDonald's in somewhere in the Midwest. Now, due to some organizational issues within McDonald's, that was rolled back. Now they're planning to roll out a new system, right? So, I mean, that will happen. It can be done by AI right now. It's not perfect. The people aren't perfect either. But that's just, I mean, that was, could have been rolled out 5 years ago, right? I mean, so that same story all over the place. Like, even when AI could do the job and could do it cheaper and better than people, the rollout is very slow because society is organized a certain way and there's a lot of momentum. And I mean, law is another thing like that, right? Like, fundamentally, right now, a great amount of paralegal work and drafting of contracts and so on can be done by LLMs. Lawyers and paralegals are using them now to do their work and then charging charging an hourly rate for an hour for what was actually 2 minutes of going on to chat gpt or DeepSeek or something, right? So, but the legal profession is in no hurry to restructure to optimize itself around the use of large language models, and there's all these protections like licenses to practice and so forth. So yeah, I really think on the one hand, Gary Marcus and other LLM pessimists are correct that some people oversell LLMs and there are limits to their general intelligence. Totally. On the other hand, I think if everyone was lazy and didn't want to work and we had a political will to just give people free money, I mean, we could reorganize society. So right now, AI would do a tremendous majority of jobs. Like, we're just not doing it. I mean, look at the slow rollout of automated convenience stores, right? Like, Amazon had these stores where camera would just take a picture of your food when you leave. Like, there's no question in my mind, like, this technology could work right now, right? Like, it's not that hard. But then, of course, people are jerks and want to steal stuff from the store, and then being policed by a RoboCop has a different social vibe than being policed by the human security guard, right? So there's all these social and psychological issues that slow down adoption. So what that means is that the bar is pretty high, right? Like, the AGI has to be way better or way cheaper than people. And when the margin is enough, then the social obstacles to adopt it will be overcome. So Caleb Chase, a friend of mine from UK who's written a bunch of books on this sort of thing, he sort of thinks the great obsolescence of human jobs will come in one huge batch, because he sort of figures, like, at a certain point you'll be close enough to AGI that the cost savings and the efficiency gain, quality gain, is just too much for people to ignore, and everyone will just have to immediately roll it out, and then it will happen like in a big wave all over the place. And I think that it might happen that way, and I think that's more because of the sort of phase transition dynamics of the human social networks making up the economy, rather than necessarily because of the AI capabilities. And yeah, I can, as another example, I can look at that in music, because I'm a musician, do a bunch of computer music stuff, right? So I mean, if you trained an LLM or a comparable deep neural net on all the music up to the year 1900 and see nothing after 1900. Like that AI will never invent neoclassical metal, grindcore, progressive jazz, hip hop, right? Like it's not going to synthesize that for music before 1900. If you ask it to put together West African rhythm with Western classical music, like it'll set a Bach fugue to a West African beat or something, which could be interesting, but it's not the same as the deeper fusion that happened to create jazz or something, right? But on the other hand, so there's missing creativity. Like you're not gonna have the next Jimi Hendrix or John Coltrane be a deep neural net of the current style of deep neural net. On the other hand, almost none of the music industry requires that, right? So if you're looking at, say, make background music for my video game or my advertisement or my movie or something, or even like generate pop song to play on Spotify for people to play in the elevator, like these are solved problems by AI music generation now. It's just record labels don't want it. The music industry doesn't want it. Musicians don't want it, right? So, I mean, the rollout there is gated by what the community of humans involved wants, rather than by what the technology already can demonstrably do.
But that situation can't last forever, right? That situation will face pressure from the market.
Yeah, clearly so. But then, but the question you ask is when, and the point is when. When is more about these social dynamics and then regulatory capture by groups that feel threatened, right? Because that can, you saw that with the medical profession for a long time. Like for a long time, we had AI that could diagnose disease based on symptoms as well or better than a doctor. We had that from rule based AI even before modern neural nets, but I mean, the medical industry will not allow that to be rolled out. I saw that in China 10 years ago, like in the waiting room in the hospital in Shanghai, they had a WeChat bot where you could just tell your symptoms to the WeChat bot, and it would tell you what was wrong with you before you went in to see the doctor. The doctor would just double check what the WeChat bot said, right? So China rolled that out in a number of hospitals that I saw personally 10 plus years ago. US, we still don't have it, right? You're just sitting in the waiting room, getting sick from the person next to you and filling out forms and listening to music for 4 hours, right? So I mean that's just because US medical regulatory establishment is much worse than China's basically. So yeah, I think Ray Kurzweil's prognostication of human level AGI by 2029 that he put out in his book, The Singularity is Near in 2005, is looking remarkably prescient, right? Like we might beat it by a couple years. We might get there 2026, 27, 28. It might be a few years slower than that. I mean, but on the whole, that seems fairly on the mark as predictions go. And I sort of am getting inclined toward Caleb Chase's idea that right around that time of the breakthrough to human level AGI is when the massive job obsolescence will occur, because it seems like there's so much psychological and institutional resistance to it that it's AI is just going to take over different industries in a weird erratic pattern, just gated by the fact that people don't want their jobs obsoleted and that the people running companies are not that savvy about AI in most verticals. Now, I think, however, Ray was too pessimistic when he said human level AGI 2029 and superintelligence 2045. Like, I don't think there will be a 16-year gap. I think there will be a gap of 1 to 3 years or something. I mean, and probably the thing slowing down the transition will be the AGI's own conservatism about how fast it wants to responsibly self improve. Because I feel like once you have a human level AGI, it should be able to increase its intelligence by an order of magnitude, qualitatively speaking, at least just by software improvements, because it's going to be a better AGI programmer than we are. And then you get into hardware improvements. I mean, if you have an AGI robotizing factories and dealing with the hardware it's not going to take it more than a couple of years to make like a radically superior batch of chips and so forth. It shouldn't be able to speed up by some small integer how fast we can roll out new chips. If it's like a human level AGI built on top of current tech that can already do math and engineering better than people in some senses. So even I think even if Calum is right, I mean we're then like what 3 to 6 years from the massive elimination of human jobs, which is a situation our social and political systems are not especially well prepared for, particularly on a global level. If you look in the developing world, but even we're not well prepared in the developed world.
Do you think the transition from AGI to superintelligence would be slowed down by the physical world? So just gathering enough materials to create enough chips to train sufficiently large model to get to a higher level of intelligence.
No, no, because I think the whole direction of training larger and larger models is sort of intellectually bankrupt. And I mean, and I think LLM already has a lot more data than I do, and it's not as generally intelligent as I am yet. So, I mean, I think on the one hand, yeah, you need a lot of computers and you need a lot of data, but I think you don't need as much data as modern LLMs have to make a human level AGI. In my view, like they already know more than you and I do within their weak ability to know things. So I my gut feel is that once we get an AGI, that AGI will be able to increase its efficiency of operation tremendously just by improving its software, right? And then it won't even need to roll out new hardware or get more data to become a super intelligence. On the other hand, of course, it will be able to design new hardware also, and there's a bit more time lag to that. But just if you look at the software stacks that we're using, like I mean, we have these servers, we have Qt and OpenCL, we have Linux, then we have like a Rust kernel on top of Rust. We have our own AGI language, Meta. We have this stack is utterly not the optimal way to implement the AGI that we're trying to build on top of it, right? Like if the AGI just rebuilt everything from the ground up without having to go through all these awkward layers that are built for human understanding and are there for historical reasons, really. I mean, I don't, I don't see a big obstacle to massively optimizing AGI into ASI. I think if there's a slowdown factor, it would be the AGI's own value system. Like not like it, even if I could rewrite my own brain arbitrarily fast, I probably wouldn't. Right? I mean, I might be more reckless than some people, but I mean, I want to survive. I care about my mental well being and that of my family and friends. Right? So I mean, you would there's an argument for sake of safety and common sense. Like you make small changes and improvements, see how they pan out in the real world, make other small changes, see how they pan out in the real world, roll back if they aren't working out. So it probably the transition from AGI to ASI will be gated by responsible self modification on the part of the AGI. This is where we hit the big challenge that I see will happen in this transition period, though. I think that you have the following sort of Scylla versus Charmides issue, a rock and a hard place issue, right? The issue is if you have multiple competing efforts at AGI, for example, an AGI arms race between the US and China, such as certain national leaders are currently advocating, right? So if you have that sort of situation, so let's say that multiple parties get a human level AGI around the same time, which is almost guaranteed to happen, right? I mean, even if you kept everything locked down, that doesn't work too well. Like someone gets poached by someone else and offered $10 million to share the trade secrets, right? I mean, we can we can see with transformers from Google to OpenAI, then back to Google and to DeepSeek and so on. You can see that you can keep things locked down a little while, but not that long, right? So if you have multiple competing parties building AGIs, then in order to have a moderated pace of advance towards superintelligence, you would need agreement from all the parties controlling the AGIs about moderating the pace of development. And you then have a really annoying arms race psychology, right? Because clearly, I mean, from where I stand right now, about the difference once we have the AGI, but it seems to me now the most likely, most responsible thing to do is not go from AGI to superintelligence at the maximum possible speed, right? Probably the most responsible thing to do will be do that by baby steps and use some experimental information gathering as you go. I mean, maybe not. Maybe the AGI will just print out a very compelling argument why upgrading to superintelligence in one fell swoop is the best thing. Maybe it'll be right. But supposing that some gradual increase from AGI to ASI is the best thing to do, that requires a lot of trust among the competing parties, right? Because US's AGI isn't going to want to go slowly if it thinks China's AGI is going fast, and a decentralized network building AGI isn't going to vote to go slowly if it thinks the centralized network that wants to make it illegal and put its developers in jail is going fast, right? So this is potentially dangerous and annoying, right? I mean, because we already have the makings of an AGI arms race, but before we actually have AGI, it's mostly a matter of humans using tools to advance their own particular sectarian interests. But if that's transmitted into the AGIs where they're driving their own development, and then what exactly happens? Because each AGI, to the extent it either implicitly or explicitly like wants to keep surviving, right? I mean, it will see that the other AGI getting to the singularity first is a threat to its own survival and to the survival of the people it loves who created it, right? Like the AGI might think like, just to save the life of my creators who I've been trained to empathize with, I need to make myself smarter and smarter before this other AGI that's ruled by these guys who literally want to kill my creators, right? And so this is sort of what our geopolitical system is tending toward now, right? I mean, and there's a possibility that having the first AGI be a sort of decentralized, open global brain can diffuse that dynamic because you'll have a sort of decentralized, open thing, which is just smarter than any of the sectarian AIs. And then more resources just get pitched into the open, decentralized global brain, and the sectarian ones can't catch up. I mean, that's a possibility, but obviously there's a lot of different uncertainties there than anyone could think of immediately.
Ben, as a last question here, what what do we do about all of this? You've sketched out a situation where it seems that we are racing towards AGI, and there might be competition to get there, and this competition could be quite dangerous. So, what do we do? Do we have different layers that or different options that we can put together to get a good outcome here?
Seems like the most plausible course to a beneficial outcome I can see is the first AGI is created by some group that wants to make it open and decentralized and doesn't care about controlling it personally and doesn't care about putting their own personal value systems in it as opposed to all the other human values. And then this first AGI has got to rapidly make a plan for secure, beneficial AGI development and rollout across the world. And then people have to choose to adopt that, right? And I mean that I don't think is unthinkable. So if you look at Steve Omahundru and Max Tegmark from Future of Life Institute, that they've written some stuff about trying to make a provably secure infrastructure for the all the technology in the world, right? And I mean, I love the idea. I mean, I've done research myself on how to make systems provably secure, both in quantum computing and in LLMs and so forth. I don't I don't think that's terribly viable to roll out in the near term. And I argued this with Steve, who I've known a long time, in an interview we did, for a couple of reasons. I mean, one is it's just a lot more expensive to do things in a secure way. So I mean, I posted a paper recently on secure transformer architecture. That will only slow things down by a factor of two or so, just to make a transformer that isn't so susceptible to prompt injection attacks. And that's just slowing down by a factor of two to protect against one kind of attack vector. It's not provably secure. If you look at homomorphic encryption or something, which you need to make AI processes really secure with respect to other people hacking in and spying and seeing what they're doing. I mean, right now that slows you down by a factor of several hundred. I did some interesting calculations suggesting you could do homomorphic encryption of complex programs with only maybe one order of magnitude slow down on a quantum computer. So interestingly, it might be that some of this security is easier when you're into quantum computing, just because of the different way quantum computers operate. But I mean, even so, it's just way more expensive to do things in a provably secure way. Adding on top of it the fact that we don't really know how to do it yet for most of the processes in our global tech stack. Like, it's a really interesting research area, but it is a research area, right? So you would be asking the world to pause all sorts of development and instead put huge amounts of money into research, fundamental provability of safety of different parts of our tech stack at a time when the US is cutting out funding for the NSF for all sorts of basic research, right? So I mean, doesn't seem plausible in that sense. And there's also the arms race dynamic, whereas if the US chose to slow itself down by making everything provably secure, like if China or Russia didn't, the US is quickly going to decide that's stupid. But suppose your first AGI thinks provable security is important, right? And suppose that first AGI then solves these tech problems faster than humans have been able to, and tells you how to make chips and operating systems and LLMs and reasoning systems and whatnot that are provably secure infrastructures. Like here's provably secure embedded Linux, version one, right? So if the first AGI is oriented towards benefit and safety for humans as well as AGIs, and figures out how to make the right sort of infrastructure. And if the first AGI manages to roll that out, I mean, then you could have a more beneficial transition. And if you want to go science fictional, this can be achieved in various ways, right? You could say the first AGI releases a botnet that just replaces everyone's OS with a provably secure OS, and then bada bing, you're done, right? I mean, that's how it would work in the science fiction story, and could happen. You can't rule it out. There's also a possible future where this comes out like global nuclear disarmament, or like treaties on biological weaponry or something, right? Where once you really have the AGI and it's there in front of you, like it's really clear, whoa, this thing is smarter than people, then suddenly the people running major world governments are like, well, okay, yes, we will adopt this safety protocol, and then the AGI presumably would roll out technology that allowed monitoring of whether the safety protocol was actually being adopted. So it seems like that's at least a plausible avenue, right? Like the first AGI leads the process of enforcing some reasonable safety for the next stage. But the reason I think that's more plausible after the first AGI is launched is that I'm hoping the first AGI can just make security by design not be obscenely expensive and difficult, which it is, it is right now. And it seems like for humans to make it not obscenely expensive and difficult will will take a long time, and the AI industry isn't going to pause for it, right? So to make this happen, you would need the first AGI to be beneficially oriented and to have a value system that makes it want to do this sort of thing. You would also need to be really good at tech. It seems like the really good at tech part is kind of falling into place, right? I mean, we don't have AGI yet, but already LLMs are remarkably good at doing different sorts of math and physics. I mean, they can't ground their math and physics activity in an overall context. So I mean, they're still missing a lot, but on the whole, the direction is the first AGI will probably be really good at math engineering and physics. So it seems like the value system part is the part that has to fall into place. I don't think that's hard on a conceptual or engineering standpoint. And I'll have some papers on that I'll present at the AGI 25 conference, which we're having in Reykjavik in August. We've had a conference on AGI R&D every year since 2006 or so. The I think it may be hard in that the value system that OpenAI or Chinese government put on their first AGI system may not end up being the right one to make the first AGI properly steward the transition from AGI to ASI. I mean, my hope is that by developing OpenCog Hyperon as a sort of hybrid multi-paradigm AGI system and rolling that out on global decentralized networks with full openness, my hope is we can get a sort of a value system that's determined by sort of informal participatory democracy among various interested parties, and we can get the right value system there. But I mean, I don't see any social guarantees here either, right? So I mean, in that sense, our species is on a very high risk, high reward trajectory by any rational reckoning. I tend to be very optimistic about how the singularity will come out in my heart, sort of based on a personal or spiritual sort of intuition about it. But if I look at the situation analytically, confidence interval is very, very wide, and there's tremendous uncertainty on all sorts of important points.
Ben, thanks for chatting with me. It's been really interesting.
Yeah, yeah. Thanks for the good questions.